seen from the universe, our precious planet is blue. It's blue due to the thin liquid layer surrounding it, the ocean. 70% of the surface of the Earth is covered in seawater. And seen from the universe, this planet, or this blue ocean, may seem empty, but if we go and move a little bit closer, we'll discover many creatures living there. Coral reefs are some of the most iconic seascapes on the planet. They're very diverse as well. But also marine ecosystems close to us here in Tromsø and in Norway are very productive and diverse. For example, the Barents Sea. And if you haven't already guessed it, I'm a marine biologist here in Tromsø, and I study the relationships among the species in the Barents Sea. I study the ecosystem structure and the functioning on the ecosystem. Species interact in numerous ways, and one of the ways that are most fundamental to the transfer of energy, that is a trophic interaction, who eats whom, often portrayed as this classical food chain, where you have the plankton that's eaten by the zooplankton that's eaten by the fish, and so on. But really, out there in nature, in the ecosystem, it's far more complex than this. It's more like an interconnected web of food chains, a network. And in this network, each species plays a unique structural and functional role. But how do we determine which role a species plays? That's a good question, and that's one of the things that I'm studying. And to study this, I use network science. But first, you have to compile the network. And this is something I've done. I've gathered information on 233 species and more than 2,000 feeding interactions, together with colleagues from the university and the Institute of Marine Research. I studied the properties of this network structure. To illustrate some of these properties of networks, I'm going to use a network most familiar to you, the Facebook network. 90% of Norwegians are on Facebook. Facebook really connects people all over the world. And it's a social network. And social networks, they have certain properties, such as community structure. Think of your own social network. You have friends from all over, from high school. They form a community, could be from work, or from other social activities or your family. When I looked at the Barents Sea ecosystem network structure, I also found that they form communities. And what I saw is that these communities are also bounded by habitats. So species interact more closely in certain habitats, for example, in the seafloor and the water column. So when I looked at the network structure, it really formed these neat communities. That's one of the properties. Another property of food webs and networks are hubs. This is an air traffic network. And look at London, Paris, and all these big cities. They're really highly connected cities. They form a lot of connection to other cities around the world, many airplanes going in and out. But also in ecological networks, such as in food webs, you find hubs. And in my Barents ecosystem food web, I saw that cod, which we're all familiar with, formed such a hub. Because it gets eaten by a lot of things and it eats a lot of stuff. So it has many connections, a highly interconnected species. This you can illustrate by the size of the node or the circle. And here you can see that the blue circles, that is a fish, they're quite large. They have many connections. And the biggest of all these circles, that's cod. That has the most connections in the Barents ecosystem food web. Then the other properties of networks, such as this internet network, they can change over time. They're dynamic. And you can see that the internet network has grown over the last decade. There are more computer users, more interactions, more connections. The world has become more connected. So networks are dynamic, they change over time, and also ecological networks change over time. And one of the things that drive changes in ecological networks is, for example, climate warming. And climate warming is happening twice as fast in the Arctic, also in the Barents Sea, where we've seen a rise in seawater temperature and a decline in sea ice. And when the environment is changing, this induces also shifts in the biological system. And some of the species that respond most quickly and rapidly to some of these changes are fish, and one of the species of the fish responding most quickly is cod. So what we've seen in the Barents Sea is a northward shift of cod in the Barents Sea, or a poleward shift, as we call it. But really, it's not only cod, it's whole fish communities that are moving polewards, such as this Atlantic community has expanded in the Barents Sea, whereas the Arctic community has retracted. And this is a study performed by some colleagues of mine. So we've seen a poleward movement of fish in the Barents Sea. What I'm interested in is what happens to the structure of the ecosystem when a fish moves poleward. And fish, as you've seen, they have many connections. So they get eaten by stuff and they eat stuff. And this forms new connections in the Arctic network, for example. And this changes the structure of the ecosystem and also the function. And what we've seen when cod moved into the Arctic network is, because of its many, many connections, it really changes the Arctic network structure. The network structure becomes much more connected. And as I said, structure is related to functioning, so that also changes the functioning of the ecosystem. We've also seen that cod is a community connector. It not only connects the whole network, but it really connects the seafloor with the pelagic, the water column community. And it changes the transfer of energy between these compartments or these communities. So, I hope that through this little tour on networks, you've learned that networks are everywhere, from social networks to biological networks, and that life did not take over the planet only by combat and struggle, but really by networking. Thank you.